Swayam Prabha. Digital India. Educated India.
Good morning. Welcome back to the course Rapid Manufacturing. We have discussed multiple modules in this course regarding design of the product, different rapid manufacturing processes, and we had been through the laboratory demonstrations. In this lecture, I will discuss about the product costing for rapid manufacturing. Product costing, when I say product costing, cost is the most accessible and universally understood measure of resource of consumption. So, cost is very important. Any manufacturing enterprise exists just to earn profit. The way is to satisfy the customers, then to earn profit out of that. So, goals of any design activities are to create product that satisfy customers. So, cost can be readily used as an important metric on which to base engineering decisions are made. So, first I will discuss cost and price structure, then we will see what are design and manufacturing costs, then we will see what are the costs in specifically rapid manufacturing. Then I will come up with a cost estimation model, then we will see what is life cycle costing. Now, when we talk about cost, in traditional manufacturing what happens, in subtractive manufacturing and rapid manufacturing, what happens in this, we have the materials, I would say a raw material suppliers. There are multiple suppliers. For instance, there are 3 suppliers here and 3 suppliers here, and in between of in subtractive manufacturing we have manufacturing. This is parts and components. The point I am trying to make here is that we have a middleman who convert the raw materials into parts and components. This is component 1, this is component 2, and these components are then combined to get the final product. We get a final product here made out of these components. But in rapid manufacturing, the raw material is directly converted into final product. In general, we do not need this components, and here we can also have assembly, which is not required in rapid manufacturing. Let us first see what are the cost and price structures. The very first cost that I would like to discuss is prime cost. Total cost is the cost of the product. Cost of the product has certain components like prime cost, then factory cost. So, what is prime cost? Direct labor plus direct material cost is prime cost. This is direct material, is known as prime cost or operational cost. Direct material is material that you can see in the product itself. In additive manufacturing, most of the material is direct because we are having negligible waste in additive manufacturing, and in subtractive manufacturing the direct material is lower than in additive. What happens while manufacturing anything? For instance, while manufacturing any product, say this bangle, it is manufactured through a subtractive process. This material has to be removed. So, direct material is that we can see. Sometimes there is indirect material. There is tool that is used to do machining on this. That tool is also deteriorated. Tool wear happens. Tool wear is the indirect material that cannot be seen directly. So, prime cost is direct material plus direct labor. So, direct labor cost is cost of actual labor used to produce the product. Direct material cost is the cost of raw or semi finished material that can be directly attributed to the product. In rapid manufacturing, we will see costs for indirect material is very less. Now, factory overhead plus this prime cost makes the cost of the goods manufactured or manufacturing cost. So, when I say factory overhead, it is the overhead cost. Overhead cost is the indirect material cost, like I said, tools, then fixtures, then nuts and bolts which are used. It is indirect material cost. So, factory supplies and lubricants, it is said lubricants is very important. Indirect labor cost. Indirect labor cost is what? Direct labor is the labor who is directly working on the product. Indirect labor is the workers who have not worked directly to produce this product, but the people who are there, who have designed the product, who are doing supervision and who did inspection. So, those, that is indirect cost. And salaries of factory clerks, this is indirect cost. Factory clerks are never related directly to the manufacturing, but their salaries have to be paid, that comes in the indirect cost. So, overhead is generally indirect. And fixed and miscellaneous costs such as rent, insurance, taxes, depreciation, maintenance and repair, utilities and small tools, this is overhead cost. So, the product cost is prime cost plus factory overhead, that is, in a way, product cost is equal to direct material plus direct labor plus indirect material plus indirect labor plus miscellaneous. Now, design and manufacturing costs. Design and manufacturing costs, first is manufacturing costs. Manufacturing costs form the basis for determining the actual recurring cost of making a product. Actual cost that is there to make a product is manufacturing cost, that we have just discussed here. This is manufacturing cost. Manufacturing costs are generally the sum of the costs from 4 primary sources. So, what are those primary sources? Number 1 is recurring labor cost. Mainly 2 things required to determine direct labor cost: the time that it takes for the person to complete the job and the wage rate. For instance, if he is paid rupees 500 per hour and it takes 2 hours to complete a job, so 500 into 2, 1000 would be the cost of completing one part. So, it is time taken by the labor or the skilled labor to complete a specific job and the wage rate of that person. So, that is direct labor. So, labor costs refer to the cost of the people required to perform specific activities. The labor cost per unit associated with an activity performed during manufacturing is determined from CL is equal to NLT LR by NP. So, what are these abbreviations here? This NL is number of people, T is time as I said, and NP is the number of units those are produced here. LR is the labor rate. So, these are the components of the recurring labor cost. Recurring means variable. In manufacturing cost, as I said, there are 4 components. First component is recurring labor cost, the second component is recurring material costs. The cost of materials associated with an activity is given by Cm is equal to Um into Cm, small c small m. So, what is Um? Um is the quantity of the material consumed as indicated by its count, volume, area or length. So, quantity of material in the terms of laminated sheets can be the number of rolls of the sheet that those are consumed. For the very small components, it can be, for filament, it can be length, the length of the filament that is consumed, or the weight of the filament, or the specific volume. If I say volume of the powders or weight of the powder, those are consumed. So, that is the quantity. So, this is unit cost of the material per count, volume, per area, per length. So, this gives us recurring material costs. The cost can be divided into 2 other major components. One of the classification is total cost is equal to fixed cost plus variable cost. The fixed cost is the cost of equipment, cost of the machines, additive manufacturing machines, those we have purchased, the cost of the software, those who have purchased, and sometimes new versions of the software have to be updated. So, that might come in variable cost. So, labor cost, because that is proportional to the number of units produced, that is a variable cost. Material is also a variable cost. So, these are recurring or variable costs. Recurring means variable. So, the allocation of non-recurring tooling is the third member here. Tooling costs are non-recurring costs associated with the activities that occur only once or only a few times. Examples of tooling costs are programming, calibration costs for manufacturing equipment, training of the people. So, these are all known as tooling costs. So, this is the third factor. And next is capital costs. Capital cost is what I called here as fixed cost. This is capital. Capital cost are the cost of purchasing and maintaining the manufacturing equipment and facilities. So, this capital cost can be given by this relation TCE by NT into T, TOP and TD. What is T here? T is length of time, again the same thing. NP is the number of units, again we had it before. CE is the purchase price of capital equipment or facility. Facility means it can be land, it can be factory room, okay, or a factory. So, this is facility. Capital equipment can be the machines, okay, the transport units, for instance maybe trucks. So, TOP is the operational time of the equipment or facility is expressed as the number of hours per year. TD is depreciation life in years, because we are talking about the capital cost. There is always life cycle cost associated with anything that we purchase. Life cycle cost that I will discuss in the end of this presentation, a brief introduction to that would be given. Always the things are deteriorating with time, and there is always a replacement value. For example, if one equipment is purchased today, after 5 years that equipment might not be of use and that has to be sold. So, that is the replacement price. We have to replace that equipment with some other. So, salvage value of that equipment in 5 years, that has to be seen. So, that is also taken into consideration. Depreciation, you can say depreciation life in years has come in the denominator here. So, these are the major components of the total cost. Now, cost versus revenue. In general or traditional manufacturing, what we say, it is something like this. We have fixed cost here. This is fixed cost, that is fixed when we start. This is the total cost or revenue. So, we have the general fixed cost here, and the variable cost is depending upon the number of units. So, this is the quantity here. So, this is quantity here. So, variable cost is something like this, that varies with quantity. This is variable cost. If I add variable cost, that is total cost is equal to fixed cost plus variable cost. If I add this to the fixed cost, it becomes a line parallel to this one, but an intercept with it. The intercept value is this one. This is fixed cost. So, this is total cost. When we sell the product, the slope of selling per quantity would be a little higher than the variable cost. It is something like this. So, this is selling price. So, this point at which the total cost that is incurred, if you see this total cost is the cost that is incurred, selling price is that we are getting back from the market. So, this point is known as break even point. This is known as BEP, where BEP is break even point. Now, this is generally in traditional manufacturing. What if I try to draw this for rapid manufacturing? Rapid manufacturing may be the fixed cost. If we try to inculcate rapid manufacturing in the present scenario, for instance, a factory has a traditional setup, and rapid manufacturing or additive manufacturing is something most of the companies have to adapt in the recent times. So, in that case, what happens? The fixed cost of purchasing some more equipment would rise. So, that fixed cost would come here, something like, let me change the color of the pen here, that would be something like this. So, this is fixed cost for rapid manufacturing, because this difference is additional RM machines. Okay. But in this case, this is the fixed cost, but in this case the variable cost would be lower. Variable cost would start from here, because now we are talking about additive manufacturing. Variable cost would be a little lower. This is variable cost for rapid manufacturing. If I add this to the total cost, so this will be something like this. This is the total cost for rapid manufacturing. Now we get a, I will put selling price in a very different color. Let me say this is the selling price. Selling price. So in maroon color we had a new break-even point here, that is, this is again a BEP. This is BEP and this is BEP. Okay. Now the break-in point is lower. Now when we see this, this is the profit. This is profit. Okay. Now in additive manufacturing, for some components where it is beneficial, the profit would be here. Now this is new profit. This is profit for additive manufacturing. So this is how the cost and revenue are related to each other in any manufacturing concern. Break-even analysis or break-even chart is very commonly used, but this is a very common model. It has certain assumptions that any product that will be produced will be sold. So we are considering that any product that is produced here, it has variable cost, those will be sold to the market, number one. Number two, the variable cost is almost a constant, it is a straight line here. In reality, the variable cost also varies. There are certain factors those comes into play, but this is the very simplified model, and this is still used to have the overall feel that when would the break even point come, or what would the payback period, at what time. We can also say with quantity it can also be time here, sometimes time can also be factor. So at what time would our investment be recovered, so that is break even analysis. Now if I put a little detail into this regarding additive manufacturing and regarding production volume, let me try to view it from a different angle. The same graph it is here, we have cost here and we have quantity here. So quantity in this case is production volume. Production volume, if you know, there are types of productions. We have job production, we have batch production. Job production is only one type of product come and we do work on that job and that is delivered to the person, to the customer. Then we have batch production, different batches come. For instance, the first batch is to produce specific kinds of the pens. So those kind of pens are produced, the second 10,000 pieces of that. Okay. Then second batch is again 1,000 pieces of second kind of pen in a pen manufacturing company. Third is mass production, in which a large number, maybe 10 lakh pieces or more than that, or very large quantity is produced. So depending upon the production volume, in traditional manufacturing what happens, the cost is something like this. If we need to produce small number, the cost is very high. If we need to produce the large number, the cost is lower. So this is known as economies of scale. It is something like this. Okay. When large quantity is produced, one can save in ordering. When we order the material, in this case it is economies of scale. Okay, this is traditional manufacturing. In additive manufacturing, this does not hold good. Though there is small change with the volume, but the slope is too low, it is something like this. This is additive manufacturing. So, this is additive manufacturing where the volume of the production does not play a big role in reducing the cost per unit. So, this is actually unit cost, I would better say. The cost per unit is reduced here. So, additive manufacturing does not play a great role in reducing the cost per unit. Let me put a logarithmic scale here. Let me say these are 10 pieces, these are 10 power to 100 pieces, this is 10 power 3000 pieces, then 10,000 pieces, 10 power 4, then a lakh pieces and so on. So, if we produce either 10 pieces or we produce 10,000 pieces, additive manufacturing cost per unit is almost same because setup is already fixed for that. But in traditional manufacturing, the setup can be made specifically because we have the special purpose machines here. Here we have special purpose machines. Here we have general purpose machines. General purpose machines are like lathe, milling, drilling, the machines which are general that can be used to do specific operation on the job and the job can be produced. Special purpose machine is like a bolt maker. In bolt maker what happens, the billet goes in and it just does forming operation first, the hexagonal bar is produced, then that is cut, threading happens and that is produced in one go. So, we use special purpose machines here. So, the cost per unit cost is reduced. However, the fixed cost is higher for special purpose machines, but the overall cost is reduced per unit. If we consider the complexity of the parts, so let me draw another curve here, this is one. In this case, I am calling this is again unit cost and this is complexity in design. In traditional manufacturing, more complex the design is, higher is the cost. So, this is traditional manufacturing. In additive manufacturing, again the line is like this, a little change but the slope is too low. With high complexity, because we have additive manufacturing system, the cost would rise only a little and we can either say the complexity is almost for free, we can say for almost free. So, in this case the same costs are there, we have same costs, almost same costs, then we have higher margins because of that and therefore higher profits. So, this is when traditional cost and additive manufacturing are plotted in the terms of complexity. So, this is additive manufacturing and this is again additive manufacturing here. So, conventional manufacturing technologies would have a higher cost. Here in general, if I put scale here, this is a standard product, this is the geometric complexity, this is a very complex product. This is the role played by rapid manufacturing in the terms of costs these days, and in the coming times these traditional machines would ever be taken over by additive manufacturing completely, or the traditional machines would be left for post processing and pre-processing areas. The main processing would happen with additive manufacturing. So, many softwares like SolidWorks, NX, Siemens NX, EOS systems, they have come up with the additive manufacturing modules now. The analysis those were being done on the products, those are to be produced or those are to be designed in the softwares are now additive manufacturing analysis. We have material libraries for additive manufacturing separately, all kinds of materials and their properties are already there. For properties of polymers, the certain models are being developed. So, these things are taking their place in a very high pace. Rapid manufacturing costs First cost in rapid manufacturing, we can call it a machine cost. Machine cost is the equipment cost. Machine costs for rapid manufacturing are largely dictated by machine depreciation. Manufacturing capital equipment is normally depreciated using a straight line over 8 to 10 years, 7 to 10 years in US, and so far in rapid manufacturing also these rules apply, representing a significant departure from costing for rapid prototyping, where depreciation is frequently applied over a shorter time scale, that is 5 years typically. Using an extended period of depreciation, it is valid so long as the equipment remains functional for that time period. So, this brings us on the second factor of machine cost, that is maintenance. So, machine cost is, one is capital equipment, manufacturing capital, okay, this is one. Second one is maintenance, this is 2. For example, in selective laser sintering machine, the equipment will generally remain functional over an extended time scale. Only some of the parts, for instance lasers, those are to be replaced. So, there are certain things rapid manufacturing costs need to be factored in a full maintenance package, including the replacement of the lasers. So, machine utilization is another area of discrepancy between cost and rapid manufacturer. We can say machine utilization. To what factor are we utilizing the machines? So, this chart represents the cost for different processes taken from a study from this book. These are the processes and materials. This is rapid prototyping, rapid manufacturing, this is conventional manufacturing. For rapid prototyping, stereolithography and epoxy resin was taken as materials. Stereolithography is the process. It took $175. And for conventional manufacturing, again the machining happened and this 1112 screw machine steel was taken, injection molding was taken, fuse deposition modeling, ABS filament was taken. So, these were the costs per kg. So, these figures suggest that rapid manufacturing will struggle to compete with conventional processes where high material volumes through the high product weight or high production volumes are involved. As we see here, when the volume is higher, the unit cost is higher here. At this point, additive manufacturing is higher. So, in this case, we can say traditional is better, and here if volume is lesser than this, here additive manufacturing is better. So, this is the dividing line. The point I am trying to make here is that high material volumes and high product weight or high production volumes are involved, rapid manufacturing has to struggle. So, with the increased use of rapid manufacture and to some extent rapid prototyping and rapid tooling, larger volumes of material are being used, and ultimately this should pave the way for lower material costs due to economies of scale. This is what I just discussed. One of the perceived benefits of rapid manufacture is the potential to create products with zero waste. This is not zero weight, not actually, this is negligible waste. Zero waste is never possible. There are always supports and some other things, those are wasted. Next is labor costs. Now, labor costs, those are associated with rapid manufacture, are lower than for machine and material costs. However, this aspect can vary due to part size, complexity, manufacturing process used, degree of finishing required, production volumes and hourly labor costs. Labor costs bring up a number of discrepancies between costs for rapid prototyping and costs for rapid manufacturing. Firstly, setting up a build on a rapid prototyping machine is a highly skilled requirement, and it is a relatively slow process. So, it is relatively expensive. Rapid prototyping is relatively expensive. Right. So, this expensive process needs to be repeated for each part that is manufactured in rapid prototyping. This cost is incurred only once the multitude of builds when a series of production of rapid manufacture is produced. So, when rapid manufacturing comes, we have higher volume, therefore, it is a little less expensive. I am just talking about the labor costs, lesser labor cost specifically. With this, I would like to have a break here, and we will meet in the next part of this lecture where I will discuss the cost models for rapid manufacturing, and we will talk more about the costing in rapid manufacturing. Thank you.